Here's an introduction to logarithms. Honestly, logarithms is probably one of my favorite things to teach. So our objective is to evaluate logarithms as the inverse of exponential functions. So if you remember how to evaluate exponents, we're just going backwards. So speaking of which, let's just talk about inverse functions first. What does it mean to be the inverse of an exponential? So inverse functions, here's how a function works. So a regular function will take just numbers, 5, 7, 9, just making up numbers here just to show you how a function works. So let's just say f is our function. F will send one number to another number, and we've seen that many times. We just got done with all these trig functions and things. So a function is just takes one number and turns it into another number. Now what does an inverse do? Well, let's just say f turned our 1 into a 5, our 2 into a 7, our 3 into a 9. The inverse of f, which we use at -1 usually, which won't be the case for logarithms, by the way, but we use this -1 just to mean the inverse of f, just getting a little abstract here. And so what it does, it would take the 9 and send it back to the 3, the 7 and send it back to a 2, the 5 and send it back to a 1. So how does a logarithm work? So let's just think about how an exponential works first. So 2 to the third, what is 2 to the third power? Well, that's 2 times 2 times 2, which is 8. Or 3 to the fourth power, which is 3 times 3 times 3 times 3, which is 81. So you guys should know how exponents work. You have some of your more difficult ones, like 5 to the 0 is 1. 2 to the -3, wouldn't that be 1 over 2 to the 3, which would be 1 over 8? We could have something like, let's go with 16 to the 1/2. What does that mean? Well, that means the square root of 16, which is 4. So you can see how this is going to get a little bit more complicated as we get into, our rational exponents and things like that. But let's first go over a logarithm, and then we'll go ahead and step on the gas a bit and go into these more difficult problems. So how does a logarithm work? Well, you can see here's the rule right here. It could be written as an exponential. So let's just say we had log base 7 of 49. And this equals y. Let's just say y. Or I'm not sure. Yeah, that says c. Let's just say y. So what this really means, if we were to rewrite it, looking at that rule up there, it would be 7 to the y equals 49. So remember, this right here is our input, 49 is our input. So normally with an exponential, we're given our exponent. And it's really easy, just like we saw right here. 2 to the third, boom, it's 8. 3 to the fourth, boom, it's 81. 5 to the 0, it's 1, and so on. We're given the exponent. Here we're not given the exponent. Instead, we're given the answer, and we need to come up with the exponent. So 7 to what power? And that's why it's an inverse, because now we're going backwards. We're thinking 7 to what power is 49? Well, that power would be 2. And that's the main way that in logarithm works. I do want to go over a couple little things, and that would be that log, if there is no base, let's just say log of 1,000. If there's no base, by default, it would be a 10. So if there's nothing there, it's not a 0, it's not a 1, it's not a 2, it's a 10 if nothing is there. So this would be 10 to what power is 1,000? Well, 10 to the third power is 1,000. So anyways, that's just an introduction to logarithms. We'll see more examples right now. I got plenty of examples. It's going to be exciting.